several of these and use that to send information back up to the MSC, and the MSC will basically keep track of the regional information and then push it back even higher. So the base transceiver station here will talk to the phone. It'll basically have an Ethernet connection or sometimes a direct radio link back up to the BSC, or it'll be on-site. BSC will go back to the MSC, and so on. It's pretty straightforward stuff, right? More interestingly over here is the MS, which talks to the BSS. Sorry, so all of this together is called the base station subsystem, and the base station subsystem is what we're going to be attacking in the demos that do not work. Okay? So the base station subsystem talks to the phone. It's in communication with the MSC. The MSC is in communication with the back-end stuff, which is the HLR, which is the home location register, and the VLR, which is the something else location register. Basically, the HLR is used for people who are on the same network. So if you have an AT&T phone and you connect to the AT&T network, you'll use AT&T's HLR, right? And that'll be a huge database that lists where you are, your phone is turned on, last time you updated it, a bunch of information like that that they will use to be able to contact you. So when a phone call comes in, it will go to the HLR. The HLR will say, yeah, that particular phone is located at this BSS, route the data to there, right? And it will get routed to that BSS, which will then send out a paging request, and the phone will, you know, like RICH, AGCH, LCH, and so on. The VLR is used for when you're roaming. So if you're on someone else's network, they will use the VLR to contact basically internationally or to contact the other networks to get information about you. So it's going to be used for authentication. And in order to do that, they have to have a lot of information from the SIM card. Most of the time, that involves going out and contacting you know, your home carrier. All right? So the HLR and the VLR are very, very important in terms of the way that a GSM network is set up, in that they are used for authentication and keeping track of all of the users. When we were doing a pen test like a year ago in Indonesia, they had used their HLR to run their web server as well. And we accidentally DOSed their web server, which we found out about when their whole network went down. So, so they were very, very upset about that. But yeah, it's their fault. They shouldn't have done it. But basically, HLR is pretty critical stuff. Okay, within the mobile GSM environment, there's a few key identifiers that are useful to know: MCC, MNC, IMSI, and the IMEI. Right. So the MCC is the mobile country code, and with the MCC, you can tell which country, basically, a specific phone number is from, or a specific IMSI is from. The MMC is the network code. So, for example, in the US, I think the mobile country code is 360, and the mobile network code for T-Mobile is 26, right? So, by having those values, I can know that a particular IMSI is from the T-Mobile in America network, or if I'm setting up a spoofing base station. So the base station, when it's part of the stuff that goes out on the BCCH, on the broadcast, is the MCC and the MMC. So mobile phones can figure out whether they're supposed to associate with that particular tower or not. So the MCC and the MCC are very important. They're the key identifiers that are used for networks within the GSM environment. The IMEI is a serial number that's burned into your phone. It's supposedly unique per device, but there are issues with that. So if you have very, very cheap, like in Thailand, what we would call China Mobile, which are MTK-based chipset phones, they're very, very cheap. They cost about $20. They usually last about a week, and then they fall apart. But it's very, very popular everywhere in the developing world. There's a lot of MTK phones. What happens is the MTK phone, when you're putting together a copied Nokia or a copied BlackBerry or something like that, you basically buy an MTK board and then you just slap on whatever case you want. So the MTK board will come with an SDK, and it has things like how to get an IMEI, or here's an example IMEI. And one of the things that happened was in India, they found that there were 20 million phones that had the same IMEI, right? So they were all using these MTK chipsets that had been pre-burned with like an example IMEI, like here's how you would set one up. And the guys that were making the phones were like, well, it would cost us 15 cents to figure out how to change it, but our profit is so slim anyway, like we'd rather keep the 15 cents, ship them. And the Indians then, recently they've had a thing where if you do not have a unique IMEI, they will bar you from the network. So they kick 20 million people off their networks, right? So apparently those IMEIs were very popular for terrorists because obviously you're one of 20 million people all with the same phone ID number, and you could buy a pay-as-you-go SIM card. So anyway, IMEIs are fairly cool. IMSIs are much better, the International Mobile Subscriber Identifier Number, right? So here's the first time you'll see this awesome graphic. I use it very heavily. Right, basically your IMSI is on the SIM card, your IMEI is on the mobile device, okay? The way that this information gets into the GSM network, which over here is shown by basically the MSC, the HLR, and the VLR, is by something called a location update request. So the first thing that happens after a phone has opened a channel is it sends a location update request, right? Phones are also on a timer, which is called, I think it's the 32212 timer, which every time that times out, it triggers a timeout and they do a new location update request to keep the network informed. And if it's turning on for the first time, it'll do what's called an IMSI attach, which is where it notifies the GSM network that the phone has now been switched on and that particular IMSI is located at this particular BTS. So basically this data gets sent up to the BTS. Part of the information that's included in that is called the LAI, which is the location area information. The LAI is from the BTS. It's part of the BCCH. Everyone remembers BCCH already, right? It's the broadcast information that gets sent out by the BTS, obviously. So the BCCH includes the LAI. The LAI gets included with the IMSI, which goes up through the MSC. Yeah? I'm seeing a lot of nodding heads. So anyway, the IMSI and the IMEI will be sent in a location update request. The location update request is also used for authentication. So the only way that a GSM network knows a particular user is who they say they are is based on the location update request handshake. So location update request goes through. If it gets all the way back to, say, the VLR or the HLR, and that particular user hasn't been authenticated for the action that they're performing, it will do a enciphering request. So the ciphering request says, let's turn on A5. And when that happens, you have to have KI, which is the secret key stored in your SIM card, in order to turn on ciphering. If you can turn on ciphering, then you're authenticated to the network. If you cannot turn on ciphering, you are not authenticated to the network. The way that an IMSI catcher works, so IMSI catchers are very popular with police. They take them to parades and riots and things like that, and they try and capture the IMSIs of all of the mobile phones of all of the people that are there. The way that that works is it impersonates the network, so it sets up a fake BTS. It broadcasts the spoofed information just using the MCC and the MMC of your target network. When the phones associate with it, one of the drawbacks with GSM is that the network doesn't authenticate to the phone authenticates to the network, right? So there's no way for the phone to know that it's not talking to the correct network. So when the IMSI catcher rolls out there and it gets a phone to associate with it, what happens is the phone sends the location updating request, which includes the IMSI information, and then the BTS says, I'm sorry, you're rejected, try a different frequency. And then the phone will reconnect to a different BTS, a real one. And in the meantime, the police have now captured the information of that particular subscriber, and they can then go to the network and they can get their information. So that's one of the ways that they use for tracking people at marches or at like the G20 stuff that happened recently in Canada, wherever it was. But yeah, it's very, very basic stuff. IMSI catching is like trivial. And I say that only because someone's doing an entire 1-hour talk on IMSI catching. Okay, so everyone is completely up to speed on GSM stuff, right? PCH, AGCH, RACH, IMSI, IMEI, no questions, right? Okay, so what I was basically tasked by my boss is to work on GSM attacks. And fortuitously enough, it coincided with these German guys developing an open source baseband for this type of phone, right? These phones cost about €5 on eBay. They have really good battery life. The design spec for the board was leaked several years ago, and there was example source code leaked as well from Telefonica in Spain. And so the German guys were able to build a functioning baseband on the phone fairly rapidly. And I've been working with that project to develop client-based attacks against the networks. My first getup was a little bit ghetto. I couldn't find the right cord, so I had to get someone to make it for me. And then the pinout that we had was for a DB9, and we couldn't find a DB9, so we bought an old modem and we hacked that up. And then we had to get a DB9 to USB, and then from the USB I was able to get that into the laptop. So it was very, very ghetto, but it did work. So using that setup, which now is done with basically a cable and one of these phones, I'm going to talk about 3 attacks now. The first attack that I put together is a very, very simple one. It's called Rachel. Unfortunately, I didn't discover it first. I'm very disappointed in this. There's a guy called Dieter Spar who talked about it last year at DeepSec. But his graphics aren't anywhere near as cool as mine. So that's cool. Basically, the way that this works is, as I mentioned, so we have the RACH request that goes out. Then you get an access grant response. Then you open a channel and you do a location updating request. And it's only at the location updating request that there's any authentication, right? So anyone can send an RACH, just like that's the way it works. So the technique with this attack is to use the phone to send out RACH, like basically RACH attacks, RACH requests, in excess of the number of channels that can be allocated by the BSS. So there's actually a strict limit on the number of channels that are available. As I mentioned, it's all timing based, so they can't just add new ones. And the number is fairly small. You can basically get about 1,000 users on a cell, right? So if you can send more than 1,000 requests, you can take down that particular cell. So we just flood requests, right? Very simple stuff. And what happens is no one else is able to use that particular cell to allocate a channel and make a phone call, right? So it takes down even emergency services, right? It's fairly cool. Unfortunately, as I said, the phone I have here doesn't support the band that we have available. And the video I wanted to make, I didn't get around to making. So if you can all just imagine I'm trying to make a phone call now and it doesn't work. I must be on AT&T. No. Right. Like I can show you the demo running and not doing anything if anyone wants to see that. But here's the graphic of the basic idea that goes on. So we take our evil attack phone and it starts sending RACH requests to the BTS. When we tested this, we thought that we were only going to be able to take out one BTS, and we thought that that would be like okay. But what we found out was we actually took out the entire area, because the way that it worked was that BTS was backed up to a base station controller that was very, very weak. And when it had all the requests coming in, we accidentally knocked over the base station controller, and like the whole tower went down. So my office was without any coverage for like half a day. It's a little bit embarrassing. So if we